Hi everyone, my name is Raina Ghazi and I have arranged for Mohi Uddin, who is our maths specialist today, to deliver our session for both Maths Primary and focusing specifically on the CPA method. So he will go through some of the key aspects of the CPA method and exemplify that using our Maths Primary resource. And also towards the end of the session, there will be time to ask any questions that you may have as well. So feel free to ask any questions. So for now, I'm going to hand it over to Mohi and yeah, that's all. Thank you.
Thank you. Hi, everyone. Welcome to this webinar. Webinar is going to focus on the CPA approach, which is one of the main components of the Singapore Maths approach. Today's content would be, firstly, Singapore Maths, focusing on what does that mean, what are the key components of Singapore Maths, and then focusing on the CPA approach in particular. And then we're going to see some of the CPA approach in action, so in lessons, and you can see that by using our Maths Primary resources. And then finally, for the last around about 10 minutes, we'll have a Q&A session as well. During the session, I will be asking you questions, and sometimes it takes a bit more time to kind of type in those questions, so we'll give everyone a good opportunity to kind of ask those questions, and I'll try to answer as many of those questions as possible. Firstly, we want to make sure that you're really confident about the Singapore Maths approach and why we've chosen to use the Singapore Maths approach. So here you've got something called a TIMSS benchmark for maths. TIMSS just stands for Trends in International Maths and Science Studies. You can type in Google search and you can see for yourself different kind of results that you see for maths and science. Here you can see that Singapore are at the top of the table. What does that mean? It means they are the leading nation in the world for maths in 2015. Now you might think that's a while ago, but these benchmarks are just like the Football World Cup. They only come out every 4 years. So the 2015 TIMSS is actually the most recent TIMSS available to us. And in 2015, they assessed, I suppose, grade 4 pupils and grade 9 pupils as well. And this is the grade 4 kind of results, as you can see. Singapore leading, the top 5 countries are in the Southeast Asia kind of region. The benchmark, the kind of average you can think of is around about here, 500 TIMSS scale center point. And I don't know if you can actually see that on your screen. I'm talking away, and I don't think you can see it for some reason. Let me just. Oh, someone's paused it. I think. Oh, give me a second. Oh, here we go. Now you can see it. So hopefully you can see that now. Apologize, something just froze there on our screen. So you can see from this table that Singapore are the leading nation, and the average, international average, is 500. So anyone above this dark green line in the middle or near the bottom are above average, and anyone below are below average. England are not doing too bad. They're around about 10th place, I think. Ireland are the leading nation. Northern Ireland are the leading nation in Europe. And you can hopefully have a chance to look at your own country, where you're from or where you're teaching, and see where they are as well. So this is kind of hopefully going to give you some confidence in the approach. Singapore, in fact, have been leading the world in maths education for 30 years. It's a long time now. 30 years to lead anything is an incredible achievement. And so it's not always been the case that they were the top nation in maths. In fact, before they became the top nation in maths, they made 3 mistakes. Firstly, they concentrated a lot on rote learning, and there are always elements of rote learning in maths, we know that. But in this case, they focused heavily on rote learning, so everything was memorized. Now, I don't know if you use 100 squares, some of us use them, and depending on how you use them, you might put your finger on 58, for example, and say, class, can you remember how to add 10 to 58? Or what happens? We jump down. And what happens if we take away 10? We jump up. So jumping up and down, for adding and subtracting 10 doesn't make a lot of sense to children. It's not very rational. And so we focused on rote learning and shortcuts, but we didn't focus on understanding maths. And so rote learning, there is a part to play in maths, but understanding has to be the key. Secondly, procedures. Singapore maths definitely has procedures, just like most countries, we have procedures. Let's take, for example, multiplying a 2-digit number by a 2-digit number. What do we say? We say multiply the ones by the ones by the tens, put a 0 there. Don't worry why, just do as I say. And then what do? Multiply the tens by the ones, then tens by the tens. And I know I said multiplication, but I'm going to put an addition sign here as well. So all of these procedures can be very confusing for children. And what's really important is trying to understand the procedure, not just showing how to do a procedure, but actually talking about why it works, what's happening here, and so forth. And then finally, one of the other 3 mistakes that they made was their extension work. We always have children that finish their work really quickly. Great, what do I do with them? And so previously, Singapore maths, what they did was just make the numbers bigger, which was a big mistake from their research that they undertook before making changes in 85. They realized that extension shouldn't just be about making numbers bigger. There's other ways to extend by keeping the children within the same lesson, but increasing the depth of understanding is more important than just having larger numbers. So those 3 mistakes that hopefully we can also learn from even now. So what are the core essentials of Singapore maths? Here are 5 that we've listed: representation, number sense, generalization, communication, and metacognition. I want to go through these 5 briefly on another screen. So I'm just going to transfer you over to another screen of mine. Here we go. Should be right up there. Right, so what do I mean by representation? Let's take, for example, 3 times 5. How do I represent 3 times 5? Am I just telling my kids that 3 times 5 is 15? Is that the only way I'm teaching multiplication? How have I started off multiplication? Can I show them that 3 times 5 can mean 5 lots of 3s? Can I draw that out like this? 1, 2, 3, 4, and 5. Can I show my children that 3 times 5 is this? 5 lots of 3s, for example. But then we also write down that 3 times 5, for example, is equal to 5 times 3. How do I show that then? Well, can I show it to make our children understand? If I put this 3 times 5 on a piece of paper, like this array, and then I rotate the paper, what do I have? I should have something like this. I have 5 times 3, 3 groups of 5s here. And you can see how they are linked by looking at this picture. This is a visualization process we're going through. We are showing our children what maths looks like. 3 times 5 is this, 5 times 3 is this. Oh, 5 times 3 is equal to 3 times 5. Why is that? Oh, it's just really rotating, right? That's all that's happening. Oh, if 3 times 5 equals 15, then 5 times 3 must also equal 15. So this is one of the key components of Singapore maths. It is a visualization. How do we see maths? How can we encourage our children to see the maths happening in front of us? And we call that representation as well. Okay, so some of us call it visualization, some of us call it representation. So another example, so that's representation. So another one of the key components of Singapore maths we discussed earlier was to be able to generalize, but also before that, something called number sense. So what does number sense actually mean? And number sense can mean something like this. When we look at 51 divided by 3, are we just telling our kids to do it in one way? Are we just thinking about 51 as 50 and 1? Is that sensible for us in this question? Maybe not so, because if we keep telling our children that 51 is made up of 5 tens and one unit, then That's one way of thinking about 51, but are we more flexible than that? Do we have a better awareness of numbers? Do we have a better number sense? If we have, then maybe we can do something like this. We can think about, oh, I know my 3 times table not very well actually, but I do know 3 times 10 quite quickly and easily. Oh, 3 times 10, what's 3 times 10? 3 times 10 is 30. So I'm going to split my 51 into 30, 40, 50, and 1. Okay, so I've got 21 left. So 30 and 21 makes 51. 51 divided by 3, oh, I can do 30 divided by 3, I know that's 10. And I can do 21 divided by 3, I know that's 7. And so, 51 divided by 3, 30 and 21 makes 51. Oh, so there are 10 threes in 30 and 7 threes in 21. So altogether, there must be 17 threes in 51. So that's an example of using being aware of numbers, being aware that 3 times 10 is 30. So then I can use that to help me solve this question. But that's not only part of it. That's not the only part. So 51 times 3 now. So we've looked at 51 divided by 3. What about 51 times 3? Am I going to just split 51 into 30 and 21 again? Or is that going to make my life a bit more challenging? Probably will do, right? So what can I do? Maybe what I could do is I can change, or I can split 51 into 50 and 1. Now that makes my life a lot more simple. Now this process of deciding really when to and how to split a number so that it makes the calculation a lot easier is something called number sense, and they work quite heavily on that in Singapore. So I'm going to go back to another one of my slides. Here we go. So here we're back to our core essentials again, and we talked about representation, number sense. Generalization is also a very important part of the Singapore Maths approach. We try to encourage our children to generalize as much as possible. So where you saw the 3 times 5 and 5 times 3, does that work for other numbers? Can you generalize that, oh, we can actually use this technique and we can swap these two numbers, and there's a special name for it we can go for as well. And so 3 times 5 equals 5 times 3, and that's a generalization. For one number, but we can generalize that for all multiplication actually. And so that's generalization. Communication is a really important part of Singapore Maths as well. And we encourage our children to discuss maths as much as possible. So where we look at a question, where we have solution, we don't have only one solution, maybe we have 2 or 3 solutions. We talk about how important having more than one solution is, how important for us to discuss each solution, which is the most efficient solution. And having those discussions are also a very important part of learning maths. And finally, we've got metacognition. Metacognition, in the most basic sense, it just means thinking about thinking. That's all it means. So can our children actually think about why they're doing something? Or is it that when I ask a child, how did you do that? Why did you do that? They don't have an answer. They actually just shrug their shoulders and say, I don't know, I just did it. I don't know. I was told to do it this way. This is how I do it. It's how my parents taught me. But can they not answer that in more detail than that? Have they not thought about their thinking behind what they're doing? Or are they just following instructions? And that's not a good way, right? Following instructions only. We need to really focus on why they're doing it. So I'm getting a question here. That sound goes off. Let me just quickly try to rectify this if I can. Okay, Louise says sound goes on and off. Can everyone hear me now? Okay, cool. So everyone can hear me, great. So I'm hoping that it will stay that way. We didn't have this issue in the morning's webinar, so hopefully it was just a one-off, and we can continue. Okay, so I'm going to move on. So we looked at the 5 core essentials. In today's session, we are actually going to focus on just one part of the 5 core essentials, which is representation. And what does representation mean? So firstly, I want you to think about this question. So we've got some time to kind of give to you as well to ask questions. How do you start to teach number work in your school? So I'll give you about a minute, let's say, just to kind of think about that and write down your questions or answers rather to this question. How do you start to teach numbers? Can you answer that question? That'd be great. So what do you use in your school to start to teach numbers? Are you just jumping onto writing numbers down? What are you doing? Why are you doing that? Great. So we have Louise says using blocks, using colored blocks. Okay, so colored blocks, and I matched them with actual numbers. Great. So Louise is saying that she they use blocks, colored blocks, and they match them with actual numbers, which is great. So if you look at using Dean's blocks, so Orla is saying that she uses Dean's. Great. So that's really good to hear, actually, because a lot of teachers are not using visual representations. Even right at the beginning, they might start it off, but then what happens, what tends to happen is as soon as the first year goes, then all the concrete and visual representations are taken out just because we feel children are ready to just look at abstract. And so let's move on. So we can see that in our Max Maths books, we start to use Dean's very early on. You can see how we represented numbers, 10 small ones, 10 small blocks, excuse me, can be made into a stick. It represents 10. Can you count up in tens? Let's count in tens, 10, 20, 30, 40. How many tens do you see? There's 7 tens. What does 7 tens make? 7 tens makes, we can count up into 70. Great, 7 tens make 70. 10 sticks can make up a board of 100 small blocks, and you can see how we're linking the visual representation to numbers. 100 is this block of 100. 10 is this stick of 10. This is one block. We always, I don't know always, but some of us dream about millions, but we've never actually seen a million or £1 million or $1 million in front of us, right? And so starting off with numbers, seeing numbers really helps children understand what they are looking at, what all the abstract stuff that they're going through, what it actually means. And so the key research behind the CPA approach is from someone called Jerome Bruner, an American psychologist. And in the 60s, he done some research which suggests that the best way, the more efficient way that us humans we learn is through this concrete pictorial abstract method. And he says that we start off using concrete materials to understand what we've got in front of us. We listen to instructions, we listen to the language and play with concrete. And that allows us to go into the next phase, which is the pictorial representation. And then it allows us to go to finally the abstract. I'll give you an example of this in real life. If you have children of your own, or if you have ever babysitted or you've been with children, we know that really small children, babies, as really early stages, we try to give them toys as much as we can, right? So here's a teddy bear, here's a car, here's whatever you want to give them, right? And we keep saying, here's your car, here's your blue car, here's your red car, until they are really aware that this is a car. And one day, out of nowhere, from nowhere, they say, oh, car. And as parents, we get really happy after a million times of saying car. They finally got it right, they can say car. And so from that concrete phase, playing around with a toy car, saying car to your child, they've got to understand, they've got to a stage where they understand that this is a car. What's the next phase? Pictorial representation, right? What happens next? As the children get older, what do? We start to read more to them, show them a book maybe. And maybe we're showing a book and there's a car in the book. And what do the children say? Oh, they point to the car and say car. Great, excellent. So we've gone from a concrete phase of understanding to then going into pictorial phase. And what's the final phase? The abstract. What does that mean in this example? Well, it means that finally children can start reading CAR is car. And they've gone through 3 phases now, the concrete, pictorial, and abstract. Now that example took a long time, right? It could take years for some children. But in a maths lesson, that can take in at 1 lesson or maybe more sometimes. We can go from concrete, pictorial to abstract, and that allows us to understand the maths in a more natural way that human beings are quite used to understanding. Any questions on the CPA approach so far? I'll give you a minute maybe just to kind of see if there's any questions or any comments. Great. So Reshma says, thank you, very clear. Great, Monica says clear. Okay, so no questions so far. So I'm going to just move on from the presentation. So I'll give you opportunities at certain points in the presentation to give questions. Here's one from Ola, so I'm just going to stop and then answer this question. Are there any particular concrete objects you'd recommend to use? Blocks work great except for large multiplication. Yeah, so there are resources and we will go through them in today's session as well. So the picture you've seen just now, they're called Deans. They're quite readily available. They're made after the Hungarian mathematician, and he came up with this concept of the Deans, which have worked really well. Unfortunately, your school may actually have the Deans in the school somewhere, but even in England and other places, what tends to happen is they're in some sort of cupboard or a storage room and no one uses them because they don't know how to use them. And so I'm sure you probably have them in your school somewhere, but it needs to be used, and there needs to be some sort of training for that as well, if you're not confident with them. So we're going to move on, and the other resources I should say as well, not just that. The Deans are great. There are other things like Cuisinier rods are brilliant. There are other resources like place value counters, absolutely phenomenal. We're going to use paper as well in today's session. Where I want to manipulate paper on the screen somehow, and you're going to get to see that as well. So we'll talk about that a bit later on. Okay. So let's move forward. So here are 4 examples, excuse me: 20 at 30, 25 at 36, 43 take away 12, 41 take away 16. And these are really interesting examples because I'm going to just choose one example, 41 take away 16. In our earlier session, today's session, I looked at the first 2 examples, 20 at 30, 25 at 36. So if you wanted to kind of catch up on those 2, you can look at the morning session that we delivered. And so today, now, I'll look at 41, and I'll look at the bottom 2 actually, 43 take away 12 and 41 take away 16. So I'm going to use a special app that I use. It should come up on your screen about now. Let me see, can you see that? Yeah, you can see that. Okay, great. So I'm going to use this app, and I find this app really useful. So I think it was something like 43 take away 12 as one question. So I've got 10 here, another 10. This normally works very well, but I think that this session here, I'm going to try to just go back a step. Give me a second. I'm just going to try to get that up. Okay. Suddenly gone. So I'm just going to go to another app of mine. So I'll use this one. Okay, so let's see. I think it was 43 take away 12, or as our first question we look at. Okay, so let's look at 43 take away 12. Hopefully your screen will catch up and you'll be blank. There you go. Okay, so we've got 43 take away 12 as our, let's say, our first question. And what I want to show you here is how we can do this. So if we're looking at column subtraction here, we would write this out as 43 take away 12, something like this. And using the CPA approach, what I would try to do first is I would try to have some sort of concrete materials in front of me. I'm going to try to see if I can get, I'm just going to pause for a second. I'm going to try to see if I can get something that I normally use. It stopped working as soon as I tried to use it here, which is frustrating sometimes. Let's see if it can work now. Yeah, so I've got this app that I normally like to use. It worked really well in today's morning session, but for some reason it's not working in this session, which is great. But I will try to use the other one. Okay, this is a really good app because it shows you the deans really clearly. I think there must be some sort of issue with the actual webinar interface and using the app for some reason, but it did work really well in the morning. So 43, so I'm going to draw 4 sticks of 10s and 3 dots for 1s, and I'm taking away 12. And so we can show by using this that if I want to take away 12, what do I need to do? I can just show that by maybe changing the color of my pen and maybe making it red. And I want to take away 12, right? So 12 is 110. So I want to take away 110. Just change the color of that. I want to take away 110 and 1. I want to take away 110 and 2 1s. So if we take 110 and 2 1s away, I'll do it 1s first, of course. Apologize for that. And then I have 1 left, and I can see I've got 3 10s left. 3 10s and 1 1's, 31. So that's a simple way of showing column subtraction in this case, whilst also using deans simultaneously. So I'm trying to use both. Now, if I was a classroom teacher in front of a class, I would try to use the concrete deans rather than the pictures I have. And the next phase could be where the children, if they are quite confident using the concrete, they can then move on to using the pictorial representations. So maybe just drawing the sticks of 10s and 1s. And we've seen that happening in many schools where the children start drawing out the 10s and 1s and they subtract from there. The challenging part is the next type of question where we have something like 52. We have something like 52, different colored pen. I'll just keep the same pen actually. 52, take away something like 13 as an example. So 52 take away 13. This is where, you know, the challenge is that we don't have enough 1s. And that's why it's so important to draw out initially, to draw out the question using concrete and visual representations. So 52 is going to be 5 10s, 1 2 3 4 5 10s, and 2 1s, 1 2. And I'm trying to take away 3 1s. Can you see straight away that I don't have enough 1s? And it's really interesting actually to see that children can see that straight away. So what do I do then? Oh, this is where our place value knowledge and how much time we've spent understanding that 10 1s make 1 10. This is what I've seen a lot of children do, which is absolutely phenomenal, because if you see that in their textbooks, sorry, in their workbooks, it shows that they understand what they're doing. So a lot of children do this. They cross out 110 and they draw an arrow like this and they draw 10. I think that's 10. They draw 10 1s. And then what they do is they say, oh, I don't have 5 10s anymore. I've got 4 10s. I can see that by looking at this picture. And now I don't have 2 1s. I have 12 1s. Some of us may call 1s units as well. In England, they've tried to change that from units to 1s. So I might use both 1s or units interchangeably. And now I can see I can take 3 1s away from the 12 1s I have, and I'll be left with 9 1s. And how many 10s do I have? I've got 4 10s here. I have to take another 10 away. So I've got 4 10s take away 1 10, that's 3 10s. So I've got 39 altogether. And so that's just an example of how the CPA approach works. I would use concrete first, then I would also use that to make sure that they understand what's happening in front of me in this screen, which is the abstract and the pictorial representations as well. So I'm going to stop. I'm going to just go back to my presentation. If I can just quickly do that. Go back to my presentation. I might just quickly stop here just to make sure that everyone's okay and everyone that has any questions in their minds can have a chance to ask. Thank you so much, Monica. She says, don't worry, I think we're getting the idea. Blocks works great, except for large multiplication, says Louise. You're right, blocks do work great, apart from large multiplication. With large multiplication, what you can do is use place value counters instead. They're brilliant. So in our books, you'll see place value counters as well. Monica says it's great, thank you. Name of the app, please. The name of the app that I was trying to use, but it suddenly stopped working in the middle of our presentation, but we resolved that issue, was called Number Pieces. It's a totally free app you can download. Can you show an addition sum? We could do addition, but I'm just wary of the time. What you could do with addition is in the morning session, we went through the first two, which is the addition. I think that's going to be live sometime soon. So the webinar that we did in the morning has the 2 addition questions in front of you, and we've gone through that. So if you look in that webinar, then you can catch up on that. Okay, Reshma says thank you. Okay, so we're going to move on. If there's no other questions, I think we'll move on to the next part of our presentation. Okay, that's good. Okay, so So as you can see, one of the key things that schools try to get right is consistency. And so whatever you're doing in year 1 has to have an impact all the way through the school to, grade 6. Because if it doesn't, then it kind of feels like you're reteaching every year, you're reteaching the same things. And that maths shouldn't feel like that. It should be quite consistent and fluid. And so you see that larger numbers, you can still use the deans like in this example here, but anything beyond 10,000 becomes quite challenging as well. And so the place value counters come in, and you can see in our books as well, we use place value counters. And so having something that allows your school to be consistent, like the books that we use, is really important, because consistency is going to just make your school excel in maths, and you're going to see the difference in the children's understanding as well. So CPA approach means seeing the maths, really. Concrete pictorial abstracts means seeing the maths. Seeing numbers initially really helps to master number work. Otherwise, children consistently find number work a challenge. But number work is not the only way that we look at, and the only way to use the CPA approach. Let's look at this. Actually, before I look at that, there's a question that's popped up, so I'm going to read that. How could we introduce place value, tens and units, for kids in the age of 5? Okay, that's a really good question. So depending on your curriculum, Zainab, I'm not sure what curriculum you use, but it depends on your curriculum. I think the best way is to use concrete materials. Something like a 10 frame are brilliant for introducing numbers up to 20, and that way you can start to see that numbers actually have a meaning. So when we write 52, is not just the way we spell 52 is 5 and 2. 5 means something. 5 means 5 tens. 2 means 2 ones. And so using something like 10 frame, using place value counters later on, but in between using the deans, they are also really very useful way of introducing number work. Ola asks, what are the name of the books you use? So we've got the Max Maths. I'll just get a picture of one here. I think you should be able to see that. It's Max Maths series. So if you go on Macmillan Education website, or just type in Max Maths, you should be able to see that on our website somewhere. Cuisine rods are works too, brilliant. They're great for young children. Thank you, Louise. Thank you, says Zainab. Okay, so we're going to go back to our presentation and stop the questions just for now. Don't worry, you will have a chance in the last 10 minutes to ask as many questions as you like in that time, but I'll hopefully have a chance to stop in between as well. Okay, so let's go back to our presentation. So here you can see like a bar, a red bar, and what I want to show you here is, what I want to say, sorry, here is that imagine this is the whole piece of paper. So I normally use something like this, a piece of paper with our children, and I would say this is the whole piece of paper. And I might set a task right at the beginning of the lesson and say, can you fold this piece of paper so that you have equal parts? How many different equal parts can you have? How many different ways can you fold it to have equal parts? And so I would let the children get on with that for, you know, a good 5 minutes and have the discussions, get it out of the system. And then I would say, okay, great, someone's got this. I'll pick one up from someone and say, well, someone's got this image. You know, you've split it into 2 equal parts. Can anyone remember what each of these parts are called? This is called a half. Why is it called a half? Oh, it's one piece out of 2 equal pieces. Is that it? Oh, it's one piece out of 2 equal pieces that makes the whole paper. Great. So it's one of 2 equal pieces that makes the whole paper. So fractions are about equal parts and making the whole, that make the whole. And so we need to reiterate that consistently with our children. Great. Someone's made this one though. What about this one? This is different to the first one we looked at. What do you think, class? Oh, you can see 4 equal parts. Can you remember what we call each of these parts? Oh, this is called a quarter, another quarter, another quarter. How many quarters do I need to make the whole piece of paper? Oh, I need 4 pieces. Can you see that? I need 4 pieces of paper, 4 equal parts, excuse me, to make the whole piece of paper. Right. So what do we call this again? It's a quarter, right? How do I write that down? So I might write down 1/4, and that's a quarter. Can you see how the 1/4, and you said there are 4 pieces that you need to make the whole? Can you see how they link together? Seeing the maths, the CPA approach is seeing the maths. Seeing the maths means more than just writing down the maths, writing down the abstract. It's more about seeing why we're writing down what we're writing down. Oh, let's look at the first one again. Oh, is there something interesting about these 2 pictures? Oh, can you see that the 1/2 is the same as 2 of these pieces? You can see that a half is equal to 2 quarters. Oh, can you understand why? It takes the same amount of space, the same amount of area there. So this is how we can get our kids to start to understand equivalent fractions, for example, because it's tempting for us just to go, if you look at this page, bottom right hand corner where the child says, I see that a half is equal to 3/6 equals to 4/8 equals 5/10, is really easy for us to just jump there straight away in our lesson and just write down exactly what that child said, and then just show that, oh, if you multiply the numerator and the denominator by the same number, then you can get the same equivalent, or you can get an equivalent fraction. But what happens there is just telling children that this is the case. Whereas if our children explore maths, see maths, and decide that for themselves, that's going to have an impact on our children more than just telling them this is it. So our books that we recommend, the Max Maths Primary Series, they have visual representations all the way through. So this was the one that we just looked at, and then it goes on and has cues for us to kind of answer the questions in the boxes, as you can see. And you can see it very clearly because the visual representations are always there. You very rarely find a page that there are no visual representations. And so the CPA approach has to be embedded in the books that we use, and we you know, we're not going to differ from that, because we know that is the best way to teach. That's the most efficient way to teach, and we've seen the results that Singapore have to kind of back that up. And you can see all the way through, not just with number work, which you've shown earlier in today's session, but also for fractions like this. And it goes on. okay, and how you can see that. Mixed numbers is a topic that children find really challenging. You know, as a math specialist, when I first started teaching, you know, mixed numbers, I didn't actually think about, you know, I just taught it in a way that I was taught myself. I didn't really think about what is a mixed number, you know, and that is something that I found really really interesting when I started to look at the Singapore approach and how they teach. So here you've got a mixed number 2.5, but you can literally see the 2 whole melons and a half a melon. But then what they're doing on top of that is showing that actually when we write 2.5, sometimes we also write 5/2, right? What do we call that? A top-heavy fraction, an improper fraction. So you can see that 5/2. Can you see 5 halves? 1, 2, 3, 4, 5 halves. So 5/2 means 5 halves, and we can literally see that. And that's the important part about the CPA approach. When we talk about and discuss the maths, our children can see what we're discussing. Because when it becomes really abstract and we just write down 5.5, 5/2, excuse me, or 2.5, sometimes a lot of our children don't understand it until they see the concrete, because they really understand the concrete, but they can't understand the abstract. I've just got a big question here, so I'm just going to try to pop that out because there's quite a lot to read there. So let me just quickly go down. I have a question actually. It's a problem that I face with my students. They have to take a lot of math subjects in the same year, like addition, subtraction, time, position, movement, fraction, division, multiplication, and a lot of other topics. Is this a good idea or concentration on the important skills they should have there early? Yeah, I think Huda's asking, which I think all of us face as teachers, whichever country we're in, and that is that there are a lot of topics to cover in a year. So what does Singapore do? It's the most successful nation in maths for the last 30 years. What do? They actually reduce the number of topics to the most core essentials for our children to move forward in the future. So initially they spend a lot of time on number bonds, a lot of time on number work, and then they start moving on to other topics such as time, position, movement. They don't neglect those topics. They look at it in a basic way, whereas they focus heavily on the more substantial topics for them that allow our children to succeed later on. Because without the basic skills, then it's hard for children to progress. Area, for example, you need to know how to multiply, and other even fractions, you need to know how to multiply and divide, for example, certain parts. So that's why it's important to get the basics right. Afnan said how to deal maths with children who has learning difficulties. Okay, great. So really good question actually, Afnan. And Asmin says children find real difficulty on converting measurements centimeters and to meters. I think most people find that, Asmin, as well. I'm going to answer Afnan's question, how to deal with children learning difficulties. In fact, 1985 is when Singapore changed the curriculum. And since 1995, they've been recognized as the leading nation in the world for maths education. How did that happen? What happened in that time? Well, when they changed the curriculum, Afnan, what happened was that they focused on those children that found learning to be a challenge sometimes. And so they said, if we can concentrate on getting it right for them, and that should mean everyone flourishes. And that's why they started off to looking at research and concluding that the CPA approach actually has to be a must-have in their curriculum. If it's not there, then those children that have learning difficulties will find maths a major challenge. So CPA approach is something that we strongly recommend. Obviously, in a webinar like this, it's hard to go through everything. It's never going to be possible. But we've gone through quite a few things. I want to kind of wrap up on one last question, which is this one: 3/4 take away 1.5. So what I do here for my children, I might ask them how many different ways, or well, not even for my children actually, for my teachers as well. I would ask them 3.25 take away 1.5. How many different ways can you solve this question? And so I would let them I'll let them have a go at that, and I'll let them come up with their solutions. So I'll give them about 10 minutes, and then I'll come back together. And so we don't have as much time, 10 minutes. So I'll let you think about that for a minute or two, okay? Or less than a minute, actually. And I want to change my screen as you think about that. And I will use this screen just to make sure that we can go through this question. So 3 1/4, take away 1 1/2 was the question. And I'll write that down here so you can also see this in front of you. 3 1/4, take away 1 1/2. Okay, that's the question I'm asking. And we've got about 6 minutes or so before we stop and have a Q&A session. So how would I solve this? What strategies would you use? If we think about it, typically a lot of us may convert the first number into improper fractions. So we might say something like 3 times 4 is 12, add the 1, so you've got 13/4. Take away 1 times 2 is 2 plus the 1, 3/2. You might have something like that, right? And then you might say, oh, this 3/2, that's not quarters, so I can turn that into quarters, right? So I might have something right on this side of the screen. I might have something like, what did I write? 13/4, take away 6/4. Is that okay? So I might have something like that, and now I can subtract, and so I'll have which is equal to 7/4, and 7/4 is equal to 1 whole and 3/4, right? Are we happy with that? So we might go through something like this. Now, if you look at that, if you look at your screen, there's quite a lot of steps that I've taken there, right? I've converted mixed numbers to improper fractions. Then I've found an equivalent fraction for 3/2, which is 6/4. And then what did I do? And then I've taken away, I've subtracted, and then finally I've made an improper fraction back into a mixed number. So a lot of skills there, right? And some children will get stuck somewhere in there. Some children make a mistake and get it wrong. So how do I simplify things? How do I get our children to see the maths? So I'm going to rewrite this question, 3 1/4, up here, 3 1/4, take away 1 1/2. Okay, how do I go about solving this then? So maybe I'll draw 3 holes, my hole here. This should all be the same size, of course. And a quarter might be something like that, okay? So I've got 3 1/4, and I might just draw these dots just to show that it's quarter as well. Okay, so I've got 3 1/4. Now I want to take away 1 1/2. So if you look at the first method that we used, it was to turn the mixed number into a improper fraction. Can we do that? Oh, we've got quarter here. I'm going to shade this in for you. We've got a quarter here. Maybe I can make them all quarters. What about that? Let's do that then. Let's make them all quarters. Look at that. How many quarters do we have? We've got 4, 8, 12, and 1 here. We've got 13/4. Can you see why we wrote the 13/4 before? And I want to take away 1 whole and a half. So I can see 1 whole is all of this, and I want to take a half away, which is this. How many quarters is that? 4, 5, 6. Oh, that's 6/4. So I'm going to take away 6/4. And what do I have left? I've got 1, 2, 3, 4, 5, 6. I've got 7/4 left. Can everyone see that? I've got 7/4 left. Great. But can I go any further? Oh, do I have any holes? Oh, I can see I've got 1 hole here. Oh, so 7/4 is equal to 1 whole. I've got 1, 2, 3/4 here. I've got 7/4, which is 1 3/4. Okay. And so you can visually see why we've just done this. Now, look at the difference. Look at the difference between this page, which is very abstract, which is not on your screen just yet. Maybe take a second or two just to come up. It should be there now. Yep. So this page, which is very abstract, and then compare that to this page, which I think you'd agree that most, if not all, our children could understand. And that's the difference that the CPA approach really has. That what do we really want from our class? Are we just looking at the top end pupils and we just want to be happy that they're doing really well, which is great? But do we want to challenge our middle and our weaker pupils? Can they do the maths? I'm sure they can. But how do I show them how to understand this in a better way? So I want to quickly go back to our webinar page. Oh, there you go. It's back. Okay, so this is where we left off. Hopefully everyone can just about see that. And finally, just to kind of wrap up our session, we've got about 10 minutes for Q&A. The key pedagogy we talked about in today's session is from Jerome Bruner, the CPA approach. He actually called it something slightly different, but we now call it the CPA approach, which is the concrete pictorial abstract approach. And it just means to start off using concrete materials. So you might ask a question, the question that we just did here, 3 1/4 to take a 1 1/2, how would you use concrete? What I would say is I would just use paper. So I would just use a square paper like this, something like this. I'll just use this and I would say, let's try to create 3 1/4. So we do that. And then can we take away 1 1/2? That was only one strategy I showed you in terms of the 3 1/4 take a 1 1/2. There are other ways of doing that as well. We can literally just take 1 away and 1/2 away, and then what do we have left, right? And so from doing something that took us about 1.5 minutes, we can just take 1 whole away and 1/2 away, and it's quick as that. So that's the impact that the CPA approach can have. Thank you for listening. If you have any questions, I'll read out any comments and questions. Feel free to ask away. You've got a great opportunity to ask me anything you feel is appropriate for this session, and I will try to answer as best as I can. Fatima says, hi, in which grade or age do you think a child should learn the multiplication table? Excuse me. Which grade or age? Times table, I don't know what you mean by learn, because for some of us, learning may mean memorization of the times table, and others may just mean to understand what 3 times 5 looks like, what it means. And that's the difference between I suppose, ideologies. And so I would say children as young as 5, 6 years old can learn the times table, but it has to be done in a way that they can see the times table. So I think one of my first kind of examples I showed you was 3 times 5 and 5 times 3, and that's a way that they can see the times table, and that's really important. Azim says it's a brilliant idea, Mohi. Thank you very much for your comments. Azim, great job, waiting for your next webinar. Thank you very much, very informative. Do you recommend Max Maths? Well, we are definitely recommending Max Maths. You feel free to kind of look at our resources on our website and have a read about what Max Maths offers you. Hi, actually, I'm wondering about the classroom management. How do they do it? In Singapore, classroom management is done in a way, I suppose, that tries to encourage mixed groupings. So, you know, in some countries, what you might do is put your strongest mathematicians in one table, and then your middle set, I suppose, and then your weaker pupils in one table. In Singapore, they don't do that. They actually try to mix the children as much as possible so that they get to experience maths and they don't feel like they're always in the bottom set, the weaker set. What about using realia? I'm not sure what that means, Chester. Thank you so much. Please discuss on time measurement in the future. Reshma says, if we adapt this to this method, do you think that the students may not feel that they need to learn how to convert fractions to improper? No, of course, yeah. Reshma says that if we use a visual approach, will they not end up on the abstract, like learning how to do it without the pictures? We definitely want them to get to that phase, Reshma. But what we're trying to get at is that it's important for them to understand what's happening in that phase rather than just blindly just do what the teacher says. So by using the concrete and pictorial representations, they get to understand why the teacher is doing what they're doing rather than just be told this is what you have to do. Just don't ask any questions and you can do it this way, right? So that's not a good way of teaching. What is your view on White Rose Maths, trying to incorporate that into our school at the moment? Lindsay, is a good question. White Rose is a scheme. I don't know a huge amount about it, but it doesn't give you the resources as much as others do, like our Max Maths. So it's just a skeleton, I suppose. So your teachers need the support on top of that, not just a skeleton, because then we're just kind of letting them go and hoping for the best again. Whereas all the schools in Singapore use textbooks and workbooks, mainly because it really standardizes the education. So you're not hoping that you've got a strong teacher in year 6 or grade 6 and you've got a weak teacher in year 3. So it doesn't work like that. The books are there to make sure that there's a minimum level of teaching going on, and that minimum is at a high level. Huda says, thank you. This was very useful. Looking forward to your next webinar. Thank you. Okay, so I think we've kind of just about run out of time. If you have any questions, you can email us or go onto our website for more information. Thank you so much for your comments and questions. Any other questions? I think we keep the questions that pop up and we will try to answer them in our future webinars.
So I just wanted to say thank you so much to Mohi. He's been here for the whole day. He's not feeling too good today, so I really appreciate his presence here. And thank you so much for your engagement and also the questions. We really appreciate your interest, particularly in our material as well. My email address will be at the end of the session, so feel free to contact me for both the CPD certificate and any more information on Max Maths Primary. And hopefully we'll be able to get in contact. So in terms of the presentation, hopefully we will have a recording of the actual session, so we'll be able to provide that for you as well. So just final point, thank you so much to Mohi, and hopefully we'll be able to see you all very soon for another session. Thank you.
Thank you.